Hello to those who have joined us already. I think we'll just give it a few minutes to let all of the attendees get on to the session and then we'll get started. So just a couple of minutes. Right, hello everyone. I think we'll just get started and those who join a couple more minutes late won't miss much other than me making some quick introductions. So thank you very much for joining our latest Michelin Scotland Innovation Park webinar, part of our Meet Our Tenant series, Scotland Leading the Battery Revolution. So good morning, thank you for joining us. And we're delighted to welcome our speaker panel today and all of you as our audience. So I'm Jill Simpson. I lead on all of our marketing and communications at Michelin Scotland Innovation Park, and I'm going to host and facilitate today's session. By joining us, I hope you've already heard a little bit about Michelin Scotland Innovation Park and our ambitious plans. If not, just to give a little bit of background, Michelin Scotland Innovation Park is transforming what was the Michelin tyre plant in Dundee into an innovation park focused on sustainable mobility and low carbon energy. You can find out more about what we are trying to achieve at www.msipdundee.com, or you can follow us on any of our social media channels under Michelin Scotland Innovation Park. So today we welcome a speaker panel that includes Colin Arnold, who is our Business Development Manager at Michelin Scotland Innovation Park, who took up that role in September, I think it was now. It's been a very quick couple of months for us. We've also got Stewart Morrison, who is the Managing Director of MEP Technologies Limited. And we have Graham Hall, who is the Managing Director of Junista Energy Limited. So we'll hold our speaker session. Each speaker will chat for about 15-20 minutes and run through their chosen topic. That will be followed by a Q&A session facilitated by myself to chat about all things battery related. A little bit of housekeeping for today. So everyone will be on mute. We will let each of our speakers present, and then we will take all of the questions at the end as part of that panel, just to ensure that things run smoothly and we don't run out of time. If you do have a question, there are two options that you can put that question to us. So you can either type your question in the question box, and I will read those out during the panel session. Alternatively, you can raise your hand by clicking on the little hand symbol, and that will alert us to the fact that you want to ask a question directly. And what we will do is during the panel session, we will take you off of mute and I will invite you to ask your question. And just allow a couple of seconds delay with the unmute function taking effect. So today's session is being recorded. It's important to let you all know that, and we will share it on our social media after the event. We hope that everything runs smoothly, but do forgive us if there are any glitches, and we thank you in advance for your patience with those and any technology mishaps that hopefully won't, but might happen. So to get started, our first speaker is someone many of you may know already. I always talk about Colin, that everybody seems to know Colin Arnold. Colin recently took up his position as Business Development Manager at Michelin Scotland Innovation Park. He has 35 years experience, which we've been chatting about earlier today, working on leading edge technology and innovation. For the last 12 years, Colin's been working on lithium ion cell and battery sector at the heart of establishing a low carbon industry in Scotland. It's something that Colin is really, really passionate about and very well connected as well. So I'll stop there. I don't want to give all of Colin's presentation away. So over to you, Colin, for your session.
Okay, thank you. Yeah, hi. So yeah, Colin Arnold, Part and Business Development Manager at MSIP. So I started in July, and again, I've been speaking to a lot of companies working in, the low carbon sector, battery and hydrogen. So I've got a really good feeling, and so is the rest of the team here, that we will make MSIP a centre of excellence for battery and hydrogen technology and other technologies as well. So if you've got the next slide, please. So again, what I'll do is I'll just give a kind of overview of where we see, the industry going and the opportunity for Scotland, and touch upon some of the key things that need to be put into place for it to be a successful, new industry in Scotland, and create lots of jobs, sustainable jobs well into the future. My two fellow panelists, experts in this industry, can give you a little bit more in-depth and technical knowledge of what they're doing. So there's a massive opportunity for Scotland. There's a lot of very good innovation happening in Scotland, and I'll touch upon that in a minute, and again, my two pals so can demonstrate that later on in the session. So looking at the global the drivers. So the global emissions regulations are getting implemented across the globe. Every country is doing something about it. Scotland should be proud of the fact that we've now got some of the most aggressive, zero emission targets anywhere on the planet. So that's fantastic, for what we need to do to save the planet, but it's also provides many opportunities for everybody that lives in Scotland. Battery prices are tumbling down. Been in the battery game for quite a few years now, and the price was always going to come down. It never quite happened, but I think it's starting to happen now. And when prices tumble, the price of EV cars gets lower cost. People buy more of them, economies of scale, and it's just it just builds and builds. And everybody talks about electric cars, but then this now impacts other sectors, marine, aerospace, and they start looking at battery, powered propulsion systems, and yeah, so it just increases. Battery technology, and again, Scotland should be proud of the fact that we're doing a lot of great things in Scotland. globally renowned for some of the research in battery technology. So batteries they are getting longer life, which is good news, for instance, for getting longer range in your cars. There's step changes in energy and power density. So smaller batteries, more miles, more power. And again, the other key thing, which a lot of people were concerned about in the early days, was reliability. Again, a lot more work to be done, but they are much more reliable. And again, I mentioned a few minutes ago, batteries, and again, Scotland can be at the heart of this as well. It's not just EVs and electric cars, it's energy storage. That's going to be a massive industry, and I think Scotland can certainly will need lots of battery energy when you think about all the renewable we're creating. Agriculture industry, marine, aerospace, and many more consumer electronics. And again, a lot of people are probably not aware of this. They all assume that the lithium battery technology started out in the Far East in Japan, but lithium use in batteries was actually invented in the UK, and it was actually one of the companies that founded AGM in Scotland, in the north of Scotland, that generated the first patent for the globe, for the world, for using lithium as a cell in a battery pack. And now I think the estimates are it's $100 billion worldwide industry. So that was fantastic back then. I think what we've got to do this time is make sure that we don't just sell our good ideas to the rest of the world, we actually take advantage of them. So there is challenges. Again, like in most industries, the Far East, especially China, are building gigafactories for fun. So they're kind of dominating the world stage along with Korea and Japan. One thing is that China, as well as selling their cells and batteries to the world, they're consuming their own output. So again, that's already been seen in the European sector, is that China's mass production, they're also consuming the most cells, and that's going to increase, and that also includes the supply base as well. So that means it's imperative that the UK, Scotland, and and Europe, generate their own manufacturing base. Again, I said that lack of manufacturing base. Well, that's something we need to do, and that's something hopefully that MSIP is going to support and push forward. There's no point having a manufacturing base if you haven't got a supply chain to support it. So again, there's a lot of good work getting done in there, identifying is there a supply chain, what more needs to be done. I'll touch upon that in a minute. And again, absolutely, we need a workforce that's trained in battery technology. And again, that's something that hopefully MSIP is going to try and rectify. So next slide, please. So yeah, just quickly going through the Scottish landscape, I touched upon it as well. There is a great history of batteries, and we're still very much at the forefront of technology. A few examples here, Amity Power, that's a company I was with just a few months ago. They're a Scottish company essentially, formerly known as AGM Batteries, way up in the north of Scotland. So they're now talking about building a gigafactory in the UK for mass production of lithium cells. It's likely that they're probably going to build 2 cell gigafactories in the UK. Hopefully one of them will be in Scotland. Again, MSIP Technologies and Genista Energy keeping Dundee on the battery map, and again they can blow their own trumpet in a few minutes' time when I finish blabbing on. Again, very unusual, but Thurso, can claim that they've got Denchi Power as well, an up-and-coming company doing some amazing things, working in the defence industry, but now they're branching into energy storage and propulsion systems on heavy vehicles. So you've got Thurso, little old Thurso up in northern Scotland's got 2 battery companies up there, and the factory's been there since '98. So there you go. St Andrews University, world leading R&D in lithium ion, and now they're doing the same for sodium ion as well. So again, they've had an excellent reputation for working this technology. And again, you're going to listen to amazing companies in a few minutes' time. And again, through my job here in MSIP, I'm speaking to countless others. So it's very encouraging that there's a lot of Scottish companies and other parts of the UK working in this sector. Next slide, please. So again, this might be a bit contentious, but it's lithium ion and hydrogen, or hydrogen. Again, I know in the 12 years there's always been this debate, especially in Scotland, that it's one or the other, and I don't think it is. I think it's both technologies. I think we're lucky in Scotland that we've got expertise, knowledge and proven experience in both technologies, and so it's not one or the other. They work together hand in hand. I mean, again, I'm happy to be challenged this as well. I'm trying to learn as much about the hydrogen as well, because we're speaking to a lot of companies in that field in MSIP. But most hydrogen propulsion systems are fitted with lithium batteries, in cars and trains, planes and automobiles, and some of the bigger systems that will be very large batteries, working hand in hand with the hydrogen aspects of the drivetrain. The renewables industry as well, again, it's both. There's parts of Scotland that are producing hydrogen on an industrial scale, for other uses, to sell the byproducts, or as longer term energy storage. So that's fantastic, and that's growing and growing at a very fast rate. But we also are producing an amazing amount of renewables. I think I've shared some facts that Scotland produces way above its demand on a regular occasion, and we've not really even started to put the mass scale offshore wind farms. So we'll be producing well in excess of what we use in electricity. So we need to store it, produce hydrogen. We'll have to store it in batteries, and those batteries go from very large scale energy storage down to a battery you might put in your garage, in your house. Lithium ion cell and battery manufacturing is already established. I touched upon some of the companies there. These are established companies. There's a lot of new companies coming through, and these are companies that are actually not just developing, but actually in manufacture. Hopefully very soon we'll have UK lithium cells to go with existing battery manufacture. The price is dropping. I touched upon that. That means that hydrogen and lithium, hydrogen prices will come down as well. So we're in a good position. Sodium ion is set to be a further 20 to 30% lower cost than the current lithium ion. So again, that just means the market expands more and more, and yeah, performance improving fast. So I think in Scotland we've got to get away from this lithium ion or hydrogen. It is both technologies. So it's not a choice. We really got to make sure we ride both horses. And again, the good news from what I'm seeing with all the companies I'm speaking to is that there's tremendous people in Scotland working on both. And again, hopefully MSIP will have these companies working literally side by side on the park. Next slide, please. So yes, the key thing here is to scale up. We're very good at innovation. We're very good at doing the prototype systems and coming up with the new ideas. Whether it's next generation chemistries like sodium ion or advanced battery management systems, more efficient ways of making it. We're very good at. We've always been good at that in Scotland. The thing we've probably not been good at in the past is not keeping the manufacturing, the large-scale manufacturing in Scotland. So that's something we need to change. That's where a lot of the jobs will come from, and that will create a sustainable, future for us, as well as obviously, reducing our emissions. So volume manufacture has to be the goal. We can't just be prototype developers. We need to get to mass scale manufacture in the UK and especially in Scotland. It generates long-term employment. There's thousands of jobs up for grabs here just on the battery sector. And if you bring these large-scale factories to Scotland, you're going to create thousands more in the supply chain. So it's critical we do this to give our next generation jobs, and also obviously some of the sectors that are maybe in decline. We need to make sure that these workers can come to this new industry. We've got the natural talent to make stuff. Always have done for hundreds of years, especially in the city of Dundee. We've always been good at manufacture, so we can't lose this. We've got to reclaim this and then build it up. We embrace lean. Again, I'm in MSIP today in Michelin. We're world beaters in lean manufacture, so we know how to do it. And again, hopefully some of the legacy of Michelin and their approach to manufacture will rub off when the tenants have come to this park. meet the challenges head on. Right, the biggest challenge that most industries got is obviously the challenge from China, and the rate of how they build their manufacturing centre up. We've got to understand that. We've got to understand whether we can compete directly with, like, say, competition from China, or whether we adapt and we look at how we can create a niche and build. And again, I've said it several times already today, but we're excellent at inventing stuff. It's amazing what Scotland has actually done in the past, and it's amazing how we're still doing that invention. It's just a natural. So we really do have to start making what we invent, as well as obviously passing it on to the rest of the world. And again, another key thing which MSIP is very much involved in, and we've got some companies up in this field, and it's a big deal for the planet, is recycling what we consume. So again, there's technology innovation in that, and it generates more jobs. Next slide, please. So I mentioned supply chain. Again, we can build factories, but factories can be built relatively quickly. But if you haven't got a supply chain, you're going to fail. So most, like in lithium ion cells, most of the materials, or raw materials, come from the Far East, predominantly from China. So I think I can't remember the exact figure. It's about 80 odd % of the materials, if not a bit more, comes from China, and China are consuming most of their own materials. So it is already creating problems, and there's already been a lot of discussion over the last few years in the UK industry, at UK government level, about how this is going to be addressed. So it's not just about building a gigafactory to make lithium cells, it's building that supply chain so that we can make the electrolytes and even the copper foils and the tabs. It's got to be made in the UK, and there's no reason why it can't. There's plenty of companies in there, they just need to be given a chance to grow. And like I said, it creates a lot more jobs. It reduces logistics, costs, transport costs, from the Far East are going up. Again, so if you can create that supply base in the UK, it reduces those costs as well. You're quicker to market, you're not getting held to ransom by companies who supply you, and then they get kind of bought over, or their entire output gets bought by a huge OEM from another country. So again, it's absolutely critical we create our own supply base in this country. And again, the diagram there you see on the slide, this is an exercise just to see the opportunities that exist. So this is just at cell level. I think this is actually a smart cell, so there's a few extra components on there. So you can see how much is involved in a cell. It's not just a few components and a bit of material. If you take that right back to raw materials, there's a lot of components, materials, processes, 2 or 3 levels down from the finished cell. So if you actually equate that to opportunities, so look how many small companies or larger companies can be created in every part of that breakdown. And again, remember, that's just the cell. So you see on the diagram, if you take it up to battery level, to automotive level, to energy storage, ISO container level, then you'll probably need a very large wall to put the breakdown, the bill of material breakdown. And again, you've got to look at this as opportunities for companies in the UK or Scotland to generate jobs and grow a company. So supply chain is absolutely critical. Next slide, please. So supply chain, you must have a supply chain, and just as important, and this is very close to what we want to do in MSIP, is generate the skills for the new industry. A lot of the technology that is being created, and Graham and Stewart will explain some of it next, is new. So there is skills that we can apply just now, and there's obviously over the next few years, there's skills that we'll have to basically define and create. But we need to do that, and we need to do it ahead of the game. So without those skills, we're not going to succeed either. And without those skills, we're not going to be able to grow, the thousands, the tens of thousands of jobs in the battery sector that we want to in Scotland. We've got a great opportunity. is moving extremely fast. It's not like the old days where there was a step growth. This sector has grown at a phenomenal rate. Things are changing on an annual basis. We need to make sure the skills are very relevant. Again, in MSIP, we're lucky to be working with Dundee and Angus College, and they are actually, intending to put a very practical hands-on skills academy on this park. That will happen. And again, we're already in discussion so that we're looking at this, we're identifying those skills, not like 3 years after they're needed, but hopefully before they're required. We'll develop courses and we'll start training before the industry needs them. And again, part of my remit here is to speak to those industries and find out specifically what skills do you need, what skills do you think you'll need, and then hopefully with the partners that we're working with here in MSIP, we'll create them and train people. And it's got to be adaptable, and it's got to change. Again, something that we're doing in MSIP, I mean, there's classroom skills, they're still very much in place, and there's some cracking classroom-based skills happening. What we'll focus on, and hopefully this will be rolled out in other parts of Scotland, is very much hands-on skills. So we'll, in terms of batteries, we'll hopefully teach young apprentices how to, wire up a battery, how to safely, repair it. Very much hands-on skills. We'll be doing it for batteries, we'll be doing it for hydrogen, we'll be doing it for other technologies as well. And again, that's why we're very keen to speak to people who want to help us define those skills, and especially the companies that are coming on this park. And again, Graham and Stuart's got a lot of expertise in batteries, so they're already been advising us on what they would like as they grow their businesses. So we're listening very closely. The UK has been very, very good at creating PhDs and MScs. St Andrews obviously, turned out quite a lot of electrochemists that are doing great things in the UK industry. And we're going to keep doing that. There's absolutely no doubts about it. But again, we really do have to remember that to create a large-scale manufacturing base, we need to train, the workers and the technicians and engineers that will actually work in the factories. And again, a key thing, especially in Scotland, we've got industries that are declining. We want to get away from fossil fuels. Scotland's been leading the world in terms of oil and gas technology. We've got an excellent workforce out there, but unfortunately it is declining. So those workers they need to come to a new sector. They've got tremendous base skills, and again, part of the Skills Academy will be generally, training the new generation, but will also be hopefully retraining those workers from other sectors, and giving them, topping up their skills with battery and hydrogen technology skills. Okay, next slide. So again, just to sum up, again, MSIP is a fairly unique project. It's one of Scotland's key projects to help achieve the very aggressive zero emission targets that we've set for ourselves. I think that in itself is a fantastic investment in Scotland, especially now with everything going through the pandemic. It's absolutely vital that we get this industry off the ground, because we're going to need to generate new industries. We're going to need to create new jobs as we try and rebuild the economy when we come out of this this kind of global crisis we're facing. So again, in no particular order, I touched upon there in the last slide, skills to order. So yeah, so this is very exciting. I think this is one of the biggest assets for MSIP, and it's very exciting. We've got a building that's already earmarked. That's going to be dedicated for a practical hands-on skills academy. We're hoping to have the first set of students on site at the start of the year in a temporary home, and then hopefully the full skills academy will be ready in 12 months' time. We're looking to, be training, through Dundee and Angus College, hundreds of students, and like I say, re-skilled workers as well. So again, anybody that's want to speak to us about what skills they think that we need to do, that's what we need to do and translate that into actual modules and courses. Batteries and hydrogen, it is batteries and hydrogen, there's absolutely no doubts about it. Again, on MSIP, I'm speaking we've got about 70 to 80 active inquiries for people that quite like to locate on the site, which is amazing considering what's going on in the world. I'd say the majority is battery and hydrogen companies at all aspects of the supply chain. There's companies that are talking about full electric vehicle to components on both systems. So this site will be, a centre of excellence, and it'll also be a manufacturing base for both technologies and all the other sectors that support that. Again, a unique site. It's a green energy oasis, I've called it. Michelin had a plan to make this site the first tyre facility, 24/7, quite a large-scale tyre facility, be entirely off-grid. So that's an amazing ambition for Michelin. Okay, Michelin's not going to be making tyres on the site anymore, so we're going to pick up that mantle, and this site will be entirely off-grid. So it'll be entirely green energy. So the different combinations of green energy, we've got up to 24 megawatt. And to put that into context, the site, it had 2 turbines, but the site was operating off a 6 megawatt brown connection to the grid. So we're extending that a lot further than that. And again, for manufacturers or developers that come onto this site, one of the questions, especially for battery manufacturers, is, yeah, but are you really reducing the carbon footprint because of the cost of manufacture? Well, we'd be proud to back up people that come on this site saying, well, certainly the energy that supplies your assembly line will be entirely green. Jobs, again, obviously, unfortunately, it was sad news when Michelin, after the length of time they were in Dundee, closed the site down. That's 850 jobs. That's a lot of jobs for a city, a relatively small city of Dundee to lose. So everybody in the MSIP team are absolutely 100% committed that we're going to replace those 850 jobs as soon as we possibly can. And again, the good news is all the companies that we're speaking to, if we can make sure that we can give them a good place to come, they're going to come and bring jobs with them. So it's 850 jobs and hopefully many more on top of that. And again, if we can create those jobs on this site, there's going to be many other jobs associated with these new companies that come in here elsewhere in the city and throughout Scotland. Collaboration. Already, again, we're still obviously building the site. It's going to take a bit of time to get the site fully, ready for, to pack with tenants, but we're already starting that collaboration. We're already signing up collaboration agreements with the agencies, St Andrews University, Dundee University, Abertay, obviously the Dundee and Angus College, and all the other universities throughout Scotland. We're reaching out to the rest of the UK and European and even international as well, companies and agencies. They might not necessarily locate here, but they're very keen to work with us. And again, that's to the benefit of the local community and also the tenant community. Supply chain, again, that's absolutely critical for batteries and hydrogen systems. So again, we're speaking to companies that are part of that supply chain. Some of those companies, they might not necessarily be the right fit for the park, or they might not want to come to the park, but if they can come to the area or to Scotland, then that's good. They bring jobs with them. I touched upon the green energy credentials. This is a perfect demonstration site. We're already speaking to companies, and again, you'll be hearing announcements very, very soon of really exciting demonstration. It's a working site, but it's also going to be a fantastic demonstration site, and that's the best combination you can get. Trying out your technology on something that's actually getting used in a real life scenario. So again, you'll be seeing lots of announcements in the next few months. And then finally, one of the concepts of this site was not just to be another industrial park that does manufacture, but it was to try and support companies who are literally, they've just had their bright idea. They've got a desk and a CAD station, and they might need a bit of a lab space. So we want to cater for those companies and every single step on their journey from TRL 1 to TRL 10. And just as important, make sure that we support them so that they can manufacture their bright idea and hopefully eventually be a tenant has got a manufacturing space and employs, dozens of jobs on this site. So again, very important we support companies from the start, and that's already starting just now. And there's a lot more information that you can find by just speaking to us or checking out our website. Okay. So that's me. I think I'm just about on time or a little bit over. So yeah, so like Jill said, please check us out, speak to us directly, go on the website, send us an email, speak to us about anything I've said today. Yeah, we're just happy to engage. Okay.
Yeah, thanks very much, Colin. I think that was great and a really good way to kick off our session today. You gave a really good solid background on Scotland's expertise, but you also gave an awful lot of detail on Michelin Scotland Innovation Park and where we fit into the landscape to complement everything else that's happening. So no, I think that was great. Thanks so much. So up next, catching up on a little bit of time, Colin did run over, but only by a couple of minutes, Colin. I'm pretty impressed. Not by a lot. So up next, we've got Stewart Morrison, who is the Managing Director of MSIP Technologies Limited. So Stewart has about 29 years experience in electronics and the automotive industry. And MSIP Technologies Limited is a future tenant of MSIP, and we're really excited to be working alongside them. So over to you, Stewart.
Sure, let's pop on to the next slide, Jill. Yeah, so thanks very much for the chance to talk, and fit nicely in with the theme that MSIP and Colin have already laid out. MEP Technologies team have been working with rechargeable battery packs for over 3 decades. Automotive, e-mobility and industrial battery pack applications. We kind of cover almost every sector. Energy storage, I'll leave to Graham, but the rest of the sectors we have many inquiries coming in every week, and therefore it's interesting and exciting time at the moment in the battery industry. In our past, we were involved in the development of and manufacture of the battery pack for the McLaren P1. So probably very few people know that, but that pack was manufactured exclusively in Dundee by, at the time, Johnson Matthey Battery Systems. The hypercar had the battery pack offered 176 kilowatts of power in less than 100 kilos. A very power dense and cutting edge, world leading battery pack, and indeed the whole car itself was a very first of its kind in penning the name hypercar. More recently, we've been developing battery systems for portable storage. So much smaller packs, but equally important, sort of 4 kilos to 15 to 20 kilos, being able to be portable so people can take them and use them in remote or difficult to areas where it's difficult to get in touch with the grid, the infrastructure. Full electric commercial vehicles and e-mobility applications as well. So it really is, as I said before, quite a next slide, please. And the next one. The important technologies for our battery industry, joining technologies. So we get involved as part of our array of technologies. We use composite bus bars, and for those who don't know what that means, it's a combination of different mixed metal types which allow us to connect with very low resistance to cells, but also, as they contain copper, provide a very low resistance path for high current applications. Other options we've got are to use laser welding, which again reduces the resistance of joints. Laser welding sounds fancy, but as Colin would know, we've been involved in that for over 10 years now. Cooling systems. Passive heat sink design. So as you can imagine, being able to take the heat out of cells is quite important. Normally they need to be supported to operate between 20 degrees and 40 degrees for optimum life. In some of our battery packs, we basically just put them in touch with a heat sink and it draws the heat out. But in some cases where we've got more extreme, either a more extreme environment or more extreme power currents, we use active heat sinking, so forced air, or in some cases forced air with a heat exchanger to liquid cooling, or liquid cooling cold plates. We've also been looking, although it's not on the slide, we've been also looking more recently at immersion cooling as well. So using a dielectric to immerse the battery pack in the dielectric fluid, and the heat dissipates directly into the fluid. The added benefit of using immersion fluids is also that from a safety point of view, they prevent the battery, or in a lot of cases can prevent the battery from going into what's called thermal runaway. So if we have a cell issue, it's very quickly, the heat's dissipated and it's extinguished. No fire, no fuss. And as part of the another important aspect of batteries is to make sure they're light, certainly for the portable and the automotive applications. We've been involved in developing batteries using aluminium composites. We've also experimented and done some prototyping with other composites such as Nomex, and for quite some time now are well aware and versed in using carbon fiber composites. So some of these are sort of more exotic materials, you may think, but to be honest, these days are becoming a lot more commonplace. Next slide, please. Lots of different cell chemistries and formats. I've got a list there. The sort of darling of the industry for quite a while now has been lithium phosphate. These have been used an awful lot in the automotive industry, are generally now being overtaken by nickel, cobalt, manganese, which is the third one on the list. But each, although I mentioned these two, each one of these chemistries and technologies has their application. What we do at MEP Technologies is take the chemistry and the battery technology and marry it to the application. Something that is a skill in itself that I'm really pleased to hear Colin say one of the things we'll be making sure we get into the local educational establishments for teaching people how to operate in our industry. A couple of other important ones on this list: supercapacitor and sodium ion. Supercapacitor we're working with at the moment is developed by a company in Stirling called RD Graphene. They're developing a graphene supercapacitor which is low cost and very high power. So again, that resonates with what Colin's saying, that Scotland really is a good place to find battery technology and associated supporting technologies that can be used going forward on the world stage. The other one I mentioned was sodium ion. Ampty Power, we worked with Ampty Power to develop one of the first automotive grade battery packs composed of sodium ion pouch cells. Just to spell it out, sodium ion has a lot of potential to become the successor to current lithium ions, because the sodium is a much more abundant element on Earth, and also has the potential therefore to be very, very low cost and very safe as well. Next slide, please. One of our specialties here at MEP Technologies is battery management. Again, a skill that's very, very important in the industry, designing and creating electronics to protect both the cells and the application from damaging the cells. At the moment, we're working on a system that is that can support a hybrid battery architecture. So the battery we are developing at the moment is composed of both lithium and supercapacitor, which allows the application to enjoy both high energy and high power all in the one application. Traditionally, choosing cells, there's always a compromise to be made between energy and power, but hopefully with this system, we can demonstrate that you can have the best of both worlds. Next slide, please. This kind of resonates with what I've already said. So high power connectivity in the battery packs is very important, and we here use the latest techniques in laser welding for high power cell connections and the composite mixed metal bus bars. The hybrid battery system we've also called pulse store. We actually have some intellectual property along with that, which again is good for both us and is a very good advert for Scottish technology. We're very hopeful that this technology will take off, and we also do, as I mentioned before, we are very proficient in choosing cooling methods for the right application. Next slide, please. I got some pictures here to show of previous projects. Some people might recognize this vehicle. This is a Modek. It was one of the very first electric commercial vehicles being manufactured from a company in Coventry back in 2007. Company is no longer in business, unfortunately, but this was really one of the very first electric vehicles on the market in the UK. The original company that I worked for, Axion Technologies, developed the battery pack that went into this vehicle. And as there are still almost 100 vehicles running around in Europe, Rome, Paris, and the south of the UK, there was a requirement to support them with new components. And we developed the battery management system to retrofit onto these vehicles. Next slide, please. This was a project we worked on 3 years ago to develop a battery pack for a classic Mini. Some of the figures there you can see, if you know batteries, 194 watt-hours per kilogram at battery level is extremely energy dense. Our brief was to create a battery pack to go in the vehicle that didn't impact the occupant's cabin. So in other words, they kept the 4 seats and people can ride in comfort. And the pack, as you can see in the pictures there, was a T-shaped pack that fitted up the centre and under the back seat. A very difficult project in terms of space, but ultimately a very good advert for our company and Scotland, because it was a difficult thing to do. Next slide, please. These are some other applications we're working on at the moment. We have a battery pack that's just gone into a 72 volt light China e-motorcycle. Density, again, this one's over 200 watt-hours per kilogram, which could, that bike is capable of over 65 miles an hour and can travel for over 70 miles and can recharge in less than an hour and a half. So it's quite a useful mobility application. And we're expecting, I think the market over Europe and elsewhere is expecting that there's going to be a huge growth in electric motorcycle and electric scooter applications in the near future. Next slide. All sorts, this one. So this is a battery that we designed for another company to be placed at the bottom of the North Sea to support harvesting energy from tidal power. Some of the difficulties in designing this were there's not an awful lot of energy to be had from tidal power, and therefore the electronics to protect the battery and monitor it had to be very, very low power indeed. So a low quiescent current drain, as I've said, and as such, maintaining the balance of the cells, again, sort of battery speak, was also very important when there was going to be long periods of inactivity. So it was another challenging application. Next slide. This is a good example of our portable applications. So in there is a 0.6 kilowatt hour battery pack, almost, that can be used by the emergency services to support equipment at fire sites. So where there's a burning building, for example, they can use these batteries in the equipment where they can't get access to the grid, and when the battery runs out, they replace it with another one, and the equipment can continue running. A very, very interesting, and as you can see, a very good application to support being able to sustain life. Next application. Sorry, next slide. Right, this is the sodium ion pack I talked about earlier. So it's an automotive grade sodium ion pack that we worked with Ampty Power on. In the sort of small picture at the bottom, you can see that it was composed of pouch cells, and these were placed into a very ruggedized case to be placed on an electric vehicle. I think that's it. I think that's probably my last slide. But I'm assuming that because I've covered it all very quickly, there'll be lots of questions after, so I'm looking forward to those. Thanks very much.
Yeah, thanks very much, Stuart. That was brilliant. Thanks for sharing all of your experience. I think it was really great to hear more about all the different projects that you've been involved in and the different applications. And you certainly managed to fit a lot into those 29 years that I spoke about before you got started.
Yeah, thanks. Oh, one of the
Oh,
things I should
yep.
say probably is that resonating again with what Colin said, we are very much working on a world stage. So probably about 60 to 70% of my inquiries come from Europe at the moment, and we also have some inquiries coming from further afield, such as India. So it's really pleasing to know that we represent both Dundee and Scotland on a world stage.
Yeah, no, I think that's excellent, and I think it's something that all of the speaker sessions will reflect today, that we're talking about national excellence here. So it's brilliant it's happening in Dundee, which is of course the best city in the world, but also within Scotland, which is the best country in the world. So we're ticking all the boxes. Yeah, so it's really good to hear.
Yeah,
so that brings us to our final speaker today, last but certainly not least. So Graham Hall has been waiting patiently. Graham is the Managing Director of Genista Energy Limited. Graham has a huge amount of experience in the battery and renewable market across Central Europe, and also has a lot of insights to share about the general trends and moves in the battery market in the UK. And it's worth noting that Graham is also participating in MSIP's first accelerator programme, which started last week. So we're really pleased that you could join us today, Graham. I know it's a really busy time for you as well. So thank you very much, and over to you.
Yep, okay. Thanks very much, Jill, and thanks to Colin and Stuart for the presentations earlier. It's really good to see what's going on at MSIP, and also the technology that Stuart's been involved in the design side inside the batteries as well. Really quite important. For my part, I'm going to try and take us a little bit about what the market's doing, and maybe that's a different slant on the battery storage side. So if Katie, you could move to the next slide, please. So I think it's a really exciting time to be part of the renewable energies and battery storage marketplace. I worked in Silicon Valley in California during the internet boom in the late 90s and the early part of 2000s. And it really feels a bit like that, becoming back to the renewable energy sector, where it feels a little bit like the internet of energy is upon us. Because there's so much news being put about what the market's doing, and it's certainly getting the headlines around the world. I think as Stuart was saying as well, whether it's being driven by the environment and the economy itself. We hear a lot about the green recovery from the COVID situation, which is obviously good news for anybody that's working in the sector, and it's good to get good news at this point in time. Because a lot of the other news is kind of negative and down. But I took the opportunity of just pulling a few headlines together, like, have I got news for you? But there's reports showing massive growth in UK energy storage projects, even over the last year, moving from somewhere about 6.9 megawatts to almost 11 megawatts in the space of a year. The clip at the bottom right there is from the UK government website, where they're basically touting that the battery storage will be the boost to the greener electricity grid. The good thing about what the government's doing there is they're doing some relaxation of some of the planning processes to make it easier and simpler for integrators to go in and put together projects that are actually going to connect to the grid. And that's going to be really important with the growth of renewable energies and the flexibility that's required in the grid as well. And I think Colin and Stuart both mentioned that there's been dramatic improvements in the battery technology. I think from Stuart's presentation, we saw a lot of that itself, just on the different types of batteries themselves and the different applications that they've got. but also with increases in the offshore wind investments and solar, the PV market. The battery costs are actually coming down, and I'll touch on that a little bit in, I think, one of the next slides as well. So if we could move to the next slide, please, Katie. Yeah, so basically, it's been talked about before. I think everybody knows that we're at a period of dramatic growth. How dramatic that growth is going to be is anybody's guess. And there are many, many different research and information points to be looked at as to where the growth is going to take us. And this is just one of them that I pulled out from a recent study as well. But it shows over like the next 15 years that we're really growing from somewhere in the region of a revenue market of around about $50 billion to maybe $500 billion over the next 15 years. And no matter what the numbers end up as, it just shows how big and the scale of what is probably in front of us. So even if these numbers were 80% accurate, then it's still a very big number at the end of the day. So to be involved at this stage with some of the technologies and some of the companies and the work that's being done at MSIP and some of the universities locally here, I think it's really, really an exciting time for everybody involved. And apologies for the pun about e-mobility being the biggest driver, but it is true. If you look at that chart on the bottom right, basically shows that the biggest increase is coming from the mobility sector. And it's not just the cars, as Stewart pointed out. There's scooters, motorbikes, bikes. Colin pointed out the applications combined with hydrogen power sources as well. And there's all sorts of different battery types included in that market number as well. So I think the theme that is coming through from the presentations that I can see anyway is there's various types and applications of technologies that can be used. There's been great improvements in performance and safety, which allows it to come about. And I did a wee bit of research, and it shows something like in the last 10 years, the price of lithium-ion batteries in particular has dropped approximately 80%. So there's been improvements in processes, there's been improvements in efficiencies, and also with the volume of scale coming about, I think that's helped so far. Where it's going to go in the future, I think it's clear that it's going to be pushed by the technology, and the price point will continue to drop. Whether it drops as fast as what is being talked about for other technologies, then I'll leave that for the experts to come up with. But another real driving point for my sector in particular is governments, cities, towns, wherever. Lots of these types of organisations are now putting out very aggressive emissions policies and targets to move to a more carbon neutral or low carbon type economy. And even just in the recent press, China got in on the act as well with their announcements, which I thought was phenomenal. And having worked for the biggest Chinese electronics company in the world with 1.2 million employees, they're really getting aggressive on those things, and they will really go after them. I know what they will do. So if we move to the next slide as well. And so bringing it more into stationary storage market, which is probably more where I'm involved personally rather than the mobility side. The numbers are still very, very big. So again, we're going from a current market value of somewhere in the region of about 10 or 12 billion dollars, going up to about $100 billion over the next 15 years. But one of the most surprising things that came out at me when I looked at these charts was everybody talks about the growth being in the Far East, China for sure, and Colin mentioned about the self-consumption that's going on there from their own batteries. China is the light blue colour at the bottom of those charts. And then the colour that's mixed up, which is the second biggest projected market, is actually in Europe. And for once, in lots of different technology type studies that you see, Europe is certainly leading North America. North America being United States and Canada. And it's quite a surprise to see the fact that Europe is adopting the technologies and the volumes that are going forward there, as being the second biggest player behind China. And in some cases, it may well actually get bigger. So it's happening across all geographies and all regions. It's happening on our doorstep. I think, as Colin has pointed out, here in Scotland, but again, my experience of working in Central Europe for the last 10 years or so as well, the many European countries are getting involved with renewable energy and battery storage type products as well. It's fairly well recognised that Germany is a leader in what's been going on in the marketplace. And I lived and worked in Germany for probably about the last 4 years before coming back to Scotland last year. And one of the things that's clear to myself is that the UK has actually got just as big a market opportunity as Germany has. And as we've been saying as well, to be located in the northeast Scotland here with the things that's going on at the universities, as well as MSIP and the other companies that are coming on stream, it really is quite exciting. But the applications and the technology are important. I think Stewart also pointed out that it depends on what type of technology you're using for the application itself. And the big thing that I work on with customers and clients is, what are they actually trying to do with the technology? What problems are they trying to solve? What jobs are they trying to do? And a lot of it is being driven by their requirements to go for a much more flexible approach. And we see that in the grid flexibility requirements as well. We see it as the demand increases for electric power. And it's only going to go and get even more so when you see the amount of electric vehicles that are going to start to get plugged into various charging stations around the country as well. So I think there's a clear indication that as we move away from fossil fuel base, the demand for electricity is going to increase, and therefore, as we've said before, there's a lot of different applications and technologies that are really important in that framework in order to satisfy that demand. So if we move to the next one, please, Katie. I mentioned that I was living in Germany for about 4 years, and one of the things that was important, I think it was 2017 it was set up, was an organisation called the European Battery Alliance. And I'm sure maybe a lot of people that are participating in the webinar today know of the European Battery Alliance, but just in case, I thought I would give it a mention, because there's a lot of activities going on to build new technologies and projects around Europe. As Colin mentioned, one of the things that we were looking at was trying to offset the reliance on the commodities coming from China and Asia. And that was one of the first and foremost goals and objectives of the European Battery Alliance. It's funded and supported from the European Investment Bank. And again, just from a European market expectation, it's expecting that the overall market for batteries and storage technology would be around about 250 billion euros by 2025. And all of this information is on the EBA website. You can go and see it for yourself. But I did participate with some of the partner companies and some of the activities that was going on when I was in Germany. It was very interesting. But again, just even looking at that market number, 2025, it's not that far away. Probably just over 3 and a bit years away, but it's going to be a very big market in Europe when you see some of the investments around. The other great thing about it is there's 500 member companies or organisations or associations that are in the European Battery Alliance framework. So it's actually a great network to tap into to keep abreast of what's going on with the technology and what the real market is doing. And they're also investing heavily in infrastructure and projects and trying to improve the new technologies in the supply chain in Europe, which brings us really back to what Colin and his team are trying to do with MSIP here in Scotland, and trying to build up the resources that are there and the companies that are able to work together. And again, if you look at just the graphic on the right-hand side, another surprising headline, and it's just from August this year, is the German government supporting and financing a battery cell factory in Sweden. So Northvolt up in Sweden are actually getting over 500 million euros assistance from the German government. So it just shows that governments are really important in influencing the markets around Europe and the cooperation around Europe. And no matter what you say about Brexit, we will still be working together with lots of these companies, whether the politics takes one route or the other. So it might be worthwhile a lot of people tapping into the resources that are there as well. So, and then just going on to, I think it's my last slide, if you move over, Katie, just a little bit about what we're doing in Genista Energy Limited. I started the company up here back in the UK after working in Germany last year. We're basically working on small to large scale projects. A small project for me is somewhere in the region of 30 to 33 kilowatt hours for a battery system with BMS and inverter included, to a large scale project. And for me, it's probably several of those container-based projects that you see on the right-hand side of the slide there, which can be up to 750 kilowatt hours in each 20-foot container, and you can marry them together. Probably the biggest system that I've been working on of late for a design is somewhere in the region of 4 to 4.5 megawatt hours, but it can scale higher than that. And like Stewart was saying as well, I'm getting project requests from a whole different range of industry sectors, utility providers themselves. There's quite a few manufacturing and warehousing type applications that companies are looking to optimize their energy outputs from, whether they've got installed PV and they want to retrofit batteries onto that in order to make their operations much more efficient, or be ready for massive increases in power demand. That's what they're trying to do. And Colin, I think, mentioned the agriculture side. The agri-tech side is also very important. You know, there's loads of farmers that are contacting me about, can I provide battery systems in order to help them with cooling and drying and various different types of applications. And a lot of the farming stock were first to take up a lot of the advantages in terms of installing PV or installing turbines when feed-in tariffs were high. As feed-in tariffs start to diminish, they're also looking for different ways of getting extended returns on their investments, and just in general optimizing their own energy sources. The healthcare sector is very important as well. So there's lots of different sectors that are intelligent, they're knowledgeable, they know what they're looking for in terms of storage and battery systems combined with renewable sources, and they're looking at all sorts of different applications as well. So the market variety is quite huge actually, but I'm seeing a lot of requests for peak shaving, you know, so that people are not, you know, pulling into peak tariff areas. Self-consumption for sure, for energy optimization, battery storage systems now going along with EV charging stations that are going installed, whether it's to offset grid consumption or in areas where grid connectivity is not that good, and also off-grid supply. I think some of the main challenges that we're seeing is what we've touched on earlier in Colin's presentation as well, and I think MSIP are doing a great job building up the resources for skills and personnel, whether it's battery technicians, hydrogen technicians, or just environmental renewable energy technicians. We're going to need more of that in the future. And the more we have on our doorstep is going to be a great addition to help smaller companies like ourselves to expand. So I think just in summary for me, I think there's great opportunities to work in partnership with various companies. I think you're seeing examples of that with Stewart, Colin and myself being on the same call today. There's lots of overlap. There's lots of areas where people can get involved, and there's a great opportunity in Scotland and in the northeast of Scotland in particular to create a lot of value for customers and clients, and create more jobs in the industry as we go forward, because the market is certainly there, and the timing is now for us to do it. And I think that's me finished as well, Katie. Yep.
Okay.
So I think we hand back to the panel.
Graham. Thank you, Graham. I think that was great. It was really insightful, and I loved that you likened Silicon Valley in the 90s to today's battery revolution. I think that one will stick with me. It's quite a good soundbite. I might use that myself in the future. So thank you very much to all of our speakers, and hopefully we've given you all a lot to think about. I previously mentioned that to ask a question you have two options. So you can either raise your hand and we will take you off of mute and invite you to ask your question directly. Alternatively, you can type a question in the question box, and we're managing that, and that will come through to us and I will read it out on your behalf. So the time is now. Get asking your questions, either typing or by raising your hand. In the interest of keeping things to run smoothly, I will direct the questions to each of the specific panelists, or if it's a more generic question, I will just pick you in turn one at a time. We have about 18 minutes, so we're going to be cutting it fine. We'll see how we get on. Hopefully we'll still have time to have quite a good engaging conversation. So I'll kick it off with the first question. So it's great that batteries and hydrogen cars will be driven by most of us in the near future. But what I was thinking about listening to all the presentations is, what's going to happen to the millions of old batteries? So will there be issues with recycling and handling those? And I think I'll put that one to Colin Arnold first, and then we'll come to the others in turn.
Yeah, well, yeah, you're right. I mean, especially the everyday cars, there's going to be, in terms of batteries, there's literally going to be millions and millions of cars. They're already stockpiling in places in the UK, so it's an issue. We can't have them sitting around, for lots of different reasons, environmental reasons, safety reasons. But the way I look at it, it's an opportunity for some entrepreneurs, and I know there's a few companies in the UK working and getting into that sector. So whether it's repurposing the battery, which is obviously a good thing, because if you can give it a second life, and again, I think my colleagues on the panel, we've been talking this for about a decade now about using old car batteries in energy storage. There is issues about that, but again, the good news is there's people working on that, how to see if it's good enough. And ultimately, batteries will need to be disposed of. So again, there's a lot of excellent, research in the UK in terms of they might not be able to be used as a battery, but we can reclaim some of the materials out of the batteries. We're even talking about getting some of the actual lithium and actually reusing the lithium, and ultimately making sure that whatever's left is disposed of correctly. So yeah, it's an industry, and it'll create lots of jobs in itself, and there's already lots of exciting technology around it.
Okay, sorry, I was on mute.
And if I could just add a quick point to that, I think on the lithium ion side, I think there's going to be a huge market for second life EV batteries in a few years' time. So I know that, as Colin said, there's a lot of work being done on that. I was involved with a couple of projects when I was in Germany as well, with one of the larger automotive manufacturers there. But I think there is going to be a real, and that might be one of the price point drivers as well, when 3 or 4 years' time we start to see a lot of EV batteries maybe no longer having the power requirements for their EV car application, being able to use in a static storage location. And they might have 10 or 15 years good life left in their batteries at that point as well. So it takes a big bit of the recycling out of the equation for a long time. So I think it's important, but it gives the industry time to look at the aspects of what Colin's describing as well.
Okay, and Stewart, have you got anything you want to add on to that?
Yeah, I mean, one of the clever bits of that research is understanding how to determine whether a battery is end of life or not end of life. It's not a very simple thing, and I know that there's been some work at St Andrews Uni. There's been lots of work all over the UK, but that's a very, very important piece of work.
Yeah,
that's excellent.
I'll just add to that to say that, like, putting Dundee on the map again, Dundee's got one of the few, there's a few in the UK that uses old Nissan Leaf batteries in one of the EV charging car parks in the centre of town. So that's an actual working one. So there you go.
A real life example. Yeah, yes. Thanks. See, and that's why you're the battery man, Colin. You know everything.
Well, I don't know. The other guys know more than me.
So our next question that's been submitted is, again, it's one for each of you. What type of battery technology will give best performance in the future? So I might start with Stewart on this one, and then we can work our way through each of you.
Oh, I hate these. They're open. How far in the future are we talking? I don't believe that we've come across the battery technology for the future yet. I think what we've got are some really good technologies that are being applied in the right applications, and obviously choosing the right chemistry, the right cells for the right application. And as we've seen, I mean, when I started in batteries about 13 or 14 years ago, at that point in time, I think the energy density was about 125, 130 watts per kilogram, and we're now at cell level at 280. So that's more than double in less than 10 years. And I think there's a way to go yet for the current technologies, but I don't think anybody's actually found what's going to be our future technology yet. There's a few hopefuls like lithium air, lithium sulfur, some solid state batteries that are being developed, but I don't think we've seen it yet. It'll be a left field one that comes from nowhere, and is whoever brings it will be the new Bill Gates of the future.
Hopefully they find it when they're at MSIP, Stuart.
Well, exactly. I'm happy to help anybody who's working on that.
Excellent. And Graham, do you want to add anything onto that?
I think it's application specific, and I think just a couple of bits of data that I put in the slide about the market growth. I think there's room for many different types of technology. So a bit like Stuart, it's hard to say. It's definitely not one size fits all. And when I look at it, it's down to price point and application, and being able to put it into a solution that makes a customer happy. So it's different technologies, different combinations, sodium ion, hydrogen, batteries, all the different types of batteries that Stewart was talking about working on. I think they've all got a place in that market.
Okay, no, that's great. So, and Colin, sorry, I'm forgetting Colin. Colin, do you want to add anything to that?
Yeah, just very quickly. I think sodium ion, perhaps not a game changer in terms of chemistry, but in terms of the fact that it could be 20% or 30% cheaper and it's much safer, that could be a big game changer on those fronts. You mentioned solid state. I mean, again, there's some work getting done on that in Scotland. Again, solid state could be another big step change. Again, I would also say a lot of the existing chemistries are getting looked at. Lithium iron phosphate, which was, Stuart mentioned, that was used heavily in early EVs, making a comeback actually, because they went in and they've just looked at not necessarily changing the chemistry, but other aspects of it. So that's getting a new lease of life. And I think one of the keys going forward, and again, a lot of this is happening in Scotland, and Stuart and Graham are well aware of this. It's hybrid systems, so it's looking at new chemistry, but it's also combining, existing chemistries. If you want power and energy, it's difficult to get that in a single chemistry. So what you do is you put them in the same battery pack. The secret is getting a control system that works. And one of Stuart's slides showed that, MEPTEC are looking at that. So yeah, a long way to go. And yeah, there's lots of exciting technologies that'll just suddenly appear, maybe out of St Andrews. And change the world.
Absolutely. Okay, well, that sounds good. Our next question, it's more of a comment around collaboration. So I'll read it out, but it says, it's from Helen Kemp, and it says, we at Carruthers Renewables would be interested in testing second life batteries for storage for the Carruthers wheel and very low head hydro. So the prototype is at Abertay University. I've seen this one in the news recently, and I know that we're connected in with them through MSIP, but it's more of a comment to put it out there around collaboration with that specific company. And thanks, Helen. I've got your link that you've shared, so I'll share that with the panel as well. So the next question we've got are, what are the critical pieces of the supply chain that we need to build in or attract to Scotland to support the growth of the battery sector? And I think I'll take that to Graham first, if that's okay, Graham.
Okay. I was thinking
Sorry,
that would
Graham.
be more for Colin, but no.
Well, I'm happy to put it to Colin.
I think we've talked about it. But from my perspective, I think it's the skills. So I think from an application and from an integration side, it's definitely the skills side. I think from the supply chain side, what's clear is we want to stop, shipping batteries halfway around the world and being tied in with other people that are maybe going to be much more demanding than small companies can handle. So I think the more smaller local type manufacturing outlets that we can be working directly with is going to drive the market the right way.
Sorry, I keep going on mute. Colin, do you have anything to add on to that?
Yeah, well, one of my slides there, he showed like a lithium cell breakdown with all the processes and going right down to raw materials. So you can see all the opportunities there for UK companies and Scottish companies. So my answer to that would be every single aspect of it. I mean, I know it's difficult, perhaps on the lithium itself, because there's certain areas in the world you get that, but the good news is there's other you can get lithium from other sources. It's very expensive just now. For instance, water. There's seemingly some lithium down the Cornish mines actually, but I don't know if it's enough to sustain the industry. And there's also recycling. But it's every aspect. There's some simple things. I mean, again, I did a bit of work on looking at the supply chain, with that graphic. And for instance, in lithium cell manufacture, there's copper and aluminium. And, that's something you would think would be done in the UK, and there's very few companies that can make rolled copper and aluminium. Sounds very simple, but we're having to bring materials like that from China, which seems a wasted opportunity. So the good news is there is companies looking at that, there is companies hoping to help in that and develop techniques to do, like I say, things like the simple stuff like copper, aluminium. And the other good news is there's a lot of chemical companies, and Scotland's got a good reputation in chemical processing, not necessarily in this sector, but there's a few companies that they're probably not aware they could join this sector. So again, it's a question of reaching out to them, educating them about batteries, and see if they can, become a supplier.
Okay. And Stuart, have you got anything to add on to that?
Well, Colin's gonna kick me because he probably should have said this, but sodium cells. Yeah. there's plenty of sodium around the coastline of Scotland, out in the sea. So we have an opportunity there, and we do have skills like Anti-Power up in Thurso around who are developing that. So we have real opportunities and we have real potential to bring those to work at that level, at the chemistry level in the supply chain. And another, I'll plug again another company, RD Graphene. So the supercapacitors, which is another option, these guys are developing the process for mass scale of graphene supercapacitors at very low cost. Another excellent opportunity for Scotland to lead the way with low cost manufacturing.
Okay, that's excellent. Some really good examples as well.
Yeah, I also think the latest situation in COVID-19 is bringing it to the forefront in people's minds as well, is the dependency on offshore supply chains. We all saw the shortages at the beginning of the COVID crisis. And I think for industries to be sustainable, we need to be looking at, as much as possible, sourcing commodities and technologies as locally as we possibly can. I think we're almost going into reverse mode in that to make it happen. And I think the capability is there to make it competitive, price-wise as well. So I think we all need to be looking along those lines.
Yeah, and again, it's important. I mean, an example is most people know that Aunties are looking at a gigafactory. They are looking at the Dundee site. We'll do everything we possibly can to persuade them they should come to Dundee. It's the best places to come. But again, I've spoken to a couple of companies that said if wherever the gigafactory goes, they will come to that location. Whether if it's MSIP, they might not come in the site, but they might come to that location because they want to be close to the large-scale gigafactory. So that's what we've got to do, because those companies might create 10 jobs or 100 jobs, and it's all part of the mix. So the more we can do of that, the better. Bring it into the UK, into Scotland.
Yeah, absolutely. Okay, so that actually brings us nicely to our next question, which is, will it be possible to guarantee sustainable and ethical supply chains? Colin, I'm going to put that one to you first to get the ball rolling.
Yeah, well, yeah. I probably know where that question comes from, especially on lithium cell production, because there's few places in the world where you get lithium, and other places are getting research. So, and as well as that, you've also got cobalt. So I think, hopefully I've got this right, but I think cobalt, generally the biggest mining sites of that is in Congo, and I think lithium in South America. So yeah, so there is concerns about the ethical practices in these areas. And again, I think there's no easy answer to that. That's where the demand is coming, and I think it's working with these countries, to try and influence, more sustainable practices, especially when they're involving the workers in those countries. So yeah, it's probably a more complex question from us mere battery experts, but yeah, it's something that needs to be tackled, for the good of everybody.
Excellent. And Stewart, is there anything you want to add on that, or do you think Colin's pretty much summed it up?
No, I think he's right. If I try and summarise it as well, if you take control of your own supply chain, you're in control of the ethics. So at the moment we're beholden to supply chain that includes Dominican Republic of Congo and South America, and because the demand is so high, the people in the supply chain aren't necessarily as ethical as we'd like them to be. And I'm not saying that's a definite, I'm just saying it's a hypothetical. But the only way to know for sure, and the only way to drive it for sure, is to take control of your own supply chain. So the more we can do at home, the better.
Okay, and Graham, is there anything you want to add on to that?
I think the guys have covered it. The only thing I could add on would be, I think that there also needs to be, obviously, continued discussions with local authorities and governments in order to make sure those messages are getting out, so that smaller local industries can be supported appropriately in order to make those decisions that Stewart was talking about. So I think that's vital as well.
Yeah, no, I think that you've all answered it excellently to explain what is within your power as companies as well. So I think that good answer from an audience point of view. So I'm just conscious of time, so I'm going to pick this one last question, and then we'll wrap things up. So this one, it starts by saying what a great webinar and thanking the panel. So I'll just share those thoughts with each of you. And the question is, are you able to source sodium ion cells at commercial quantities for automotive projects yet? And I'm going to throw that one to Colin first, just to try and be fair.
Yeah, well, again, I mean, I've spent 4 years in my previous company working with sodium, and I think Stewart has as well, you know, putting sodium cells into battery packs. So I'm obviously a few months behind the curve being at MSIP, but I believe the progress on the development is working really well. Again, you know, university we're working closely with, St Andrews University are very much involved in, you know, accelerating, you know, getting to commercial level quickly. So I would say that yeah, ahead of schedule. I think commercially available in a couple of years, hopefully mass produced in the UK first. There's 30% price reduction. Again, you know, as with all products, will probably take a couple more years to get down to that, you know, minus, you know, 20% compared to lithium, just due to economies of scale and developing the supply chains. But I would say, from listening to my old friends at AMT, you're looking at 1 to 2 years from the first commercial sodium cells.
Excellent. That was a much more specific answer than I was expecting, Colin. Stuart or Graham, do you have anything you want to add on to that one before we wrap things up?
Yeah, I'll add. So, I mean, if it's a genuine inquiry, AMT would be the right people to ask. If it's something that needs support, we've got a battery management system that supports sodium and supercapacitor technology. So happy to be involved. If it's a general question, then I think Colin's answered it. It's a couple of years away, but certainly companies that are interested in that technology, now is probably the time to start looking at it, so that you get your development done and out of the way, and you're ready to catch the wave of that commercialism. Yeah,
well, just to add to that as well, again, I'm just boosting Scotland being first. So, and Stuart knows this as well, like AMT started on the sodium ion. There's a lot of companies around the world looking at it. It's a big race to try and get there first. AMT was the first company that we're aware of anywhere in the world that produced the largest lithium cell up in Thurso, the biggest production run, and I think Stewart was one of the first, or the first company, we believe, that put it into a proper battery pack and demonstrate it going down to 0 volts. So I think there's quite a few firsts there for Scotland.
Yeah.
Brilliant. And Graham, is there anything else you want to add on to that?
It's not my strength. I'm more in the static storage applications than the mobility side. So I'll defer to the other two experts on that one.
Excellent.
Graham, hopefully you'll be using sodium cells in your ISO containers soon.
Yeah.
No, that is brilliant. So yeah, just very conscious of time, and we are out of time now. And we've had a lot of comments coming in alongside the questions, praising the quality of each of the speakers, and saying that it's been really informative and interesting. So I just want to share those thanks from the audience as well as myself. So thank you, Colin, Graham and Stuart, for sharing your backgrounds with us today and some of the insights and hopefully what the future might look like in this area. So yeah, we're out of time. I would say we've still got a lot of questions that we've not managed to answer, and we could follow up with those. But if you have anything further that you would like to speak to the panel specifically about, you can get in touch with us at info@msipdundee.com. Or reach out to us on social media, and we'll be able to pick that up and make those introductions and connections to the panel. So feel free to do that. And other than that, have a really great day. It's now lunchtime, so that's good news for most of us. And we look forward to hearing you at our next webinar soon. Thanks, everyone. Bye.
Thank you, everybody.
Thanks a lot, folks. Bye.